Hello and welcome to the SUSECon and to our session, the Cloud Mastery, Elevating Automation with SUSE and IONOS. Yeah, this is me, Tobias Müller, and this is my colleague Noah. And this is the agenda of today's talk. So we would just tell you the project goals, then we will switch to the technology deep dive. We will tell you about the challenges we met with IONOS, with SUSE, with the customer, and how we solved them. And then we will come to the project outcome, and we stand here for some Q&A. So a quick introduction. I'm Tobias Müller. I'm a senior DevOps engineer at the IONOS. And we are doing Kubernetes for multiple years, all with automation, with deployment of SUSE services like Ranger, like NeuVector, like Longhorn. And we're using them in conjunction with automation to deploy these services in an automated manner. So.
Yeah, and I'm Noah, professional DevOps engineer at IONOS. And at IONOS, we are doing the whole ecosystem around DevOps. So we are doing inner source and open source. We have a strong mindset in both. Strong partnerships with open source companies like SUSE. For many years, we have a 10-year partnership with SUSE and are leading service providers in the open source ecosystem. We have many years of knowledge in that field, in the whole, from development to deployment, the whole road, the whole life cycle, I would say, with an excellent team around the globe, so we can support our customer and clients around the globe, around the clock, in many countries, with a motivated team, so the client can focus on their core business. All right, tell us about the goals.
Yeah. So we are starting. The customer wanted us to deploy an automated platform on a hyperscaler so that they can deploy Kubernetes cluster and other services seamlessly on IONOS. They want to be cloud agnostic. That means we shouldn't use as much as possible services from the cloud provider because they wanted the ability to switch to different cloud providers if needed, or to do some sort of multi-cloud strategy, or to do hybrid cloud with their on-premise data center. And they had already a contract with IONOS. That's why we partnered with them and SUSE to do the work on their hyperscaler. So on the other hand, they wanted a one view of their environment, especially the Kubernetes environment, which was new for them. So this was the reason why we choose SUSE Ranger, because with SUSE Ranger, we could the one view of all their clusters, nevertheless where they run, even if it's on IONOS, if it's on-premise, if it's on AWS or Azure, or any other supported cloud vendor that SUSE has integrated, or with some custom clusters, you can run it everywhere. The other thing was they wanted to use an open source tool set because they are a public customer and they are strong in digital sovereignty. So they wanted to be ensured that not one vendor can cut them off. VMware on Broadcom, for example, is such a thing which is hitting now the industry. So that's what I already told. We need to provide a platform as a service because they wanted their own platform as a service and not platform as a service from one of their cloud provider. And it had to be compliant with the BSI, because they are a public customer. They need to ensure that those regulations are hit and that they are safe to run their workload in the public cloud. So the motivation of the project was, as I told you, digital sovereignty, to use open source technology, to have their own hands on their environment, on their services. And we had the flexibility to start on a greenfield. It means they are new on this hyper cloud from IONOS. They have no other infrastructure there, so we couldn't start planning and evolving this whole thing and automate everything from startup, so we don't have technical depths that some other companies may have when they start on premise, or when they already started on the cloud and have already existing service running, we had the advantage to start on the greenfield. And that's why we couldn't avoid manual configuration in, I would say, 95% of the case. So now it's good.
Yeah, for our partners, obviously, we chose SUSE as one of our partners for this project, as we had a long-term partnership with them, and SUSE's cloud stack already on-premise for most of our customers, so we have deep knowledge with all the SUSE technology, and it also fits the open source mindset, which is perfect in this customer case. SUSE Rancher is the Kubernetes platform, for the Kubernetes management platform. Toby already told you it's perfect for the one view, for the multi-cloud environment, and act as cloud agnostic platform in this case. SUSE Neuvector in the security context to make sure the container platform is secured from DevOps, from build to production in every context. And it supports the full life cycle, which is perfect in this case. Can be used centrally, but also distributed across the clusters and the VDC and different locations of the platform. And it's independent from the underlying infrastructure, which is perfect as well if you want to combine on-premise solutions with cloud and other things. And so the Longhorn is storage to have minimal dependencies on the underlying infrastructure as well. And IONOS as the second partner in this project because they're a European country, European company, and have a headquarter in Germany, which is important for the customer, German data centers, and all the necessary certifications from ISO 20001 and by C5 certification. They were mostly on infrastructure as service. They are currently heading to platform as a service, but to that time they were mostly on infrastructure as service. That's why we built on the infrastructure and service as service and not on the platform as a service part of IONOS. All right. Which tool did we use?
Yeah. When we started, the question from the customer was what tools should they or should we use together with them? And in the open source ecosystem, there are a lot of tools for the specific need you need to fulfill. So, for example, we currently choose Terraform in combination with TerraGrant, but you could also use Pulumi or some Cloud Foundry stuff or anything. And on the other hand, we choose SUSE Ranger, SUSE Neuvector, Longhorn. We choose Argo CD for the GitOps part. We choose Ansible for the configuration management, OpenSAMS as the firewall solution. And last but not least, we choose GitLab to store all the code, all the automation, and used it for the CI/CD part to run all the automations that couldn't be run directly through Argo CD. So here a little combination. As I already told, we have Terraform and TerraGrant. We could use something like Pulumi, Ansible. On Ansible side, we have Chef or Puppet, but due to our experience with Terraform, with Ansible, we stick to that. Also, we have a lot of modules and resources that we could reuse for the customers. The same is like SUSE Ranger. It's, as far as I know, one of the single solution that will give you this one view and is open source. On the other hand, you could use some cloud or Kubernetes managed by the service provider, but that wasn't a use case for these customers. SUSE Neuvector is a little bit standalone because it's one of the open source platform that combines all the cloud native security. You have a lot of tools for single use cases. For example, you have Kyverno, you have StackRox, you have Falco, which all do individual tasks, but this is something the customer then has 3 tools, where instead of SUSE Neuvector, they only have 1 tool to use. And what was important for the customer, since the technicians are not so familiar with Kubernetes, They wanted an UI where they can handle everything. Even when it's automated through the Kubernetes CRDs, they wanted to have a UI to view what's happening in the cluster, what do the policies, what is active, and so on. The same is with SUSE Longhorn. You can use Ceph or a lot of other storage products in the cluster, but the fun fact of, or the advantage of SUSE Longhorn is that the usability is a lot easier than most of the things. Then, as Noah already told, it's cloud native. You just install it, it uses all the storage on the node, and you're good to go, and you don't have to do a lot of configuration like other solutions. And yeah, even when SUSE has its own CI or continuous delivery platform with Ranger Fleet, it's currently not that major than Argo CD, for example. So that's why we stick with those products. Also, here is our experience much more the favorite than Ranger Fleet, which is still not that compatible to Argo CD, for example. So now we started a project, and we had the typical chicken and egg problem. We wanted to start something, and it should always be automated, but where would you start automating when you have nothing? So that's why we choose to start it with we called it automation VDC, where everything starts. So where we build some VMs, where we introduced the first Kubernetes cluster, where we then luckily already had a GitLab instance that we could use. So later on, we will deploy our own GitLab instance for the customer. But we started with our own GitLab instance that we already had and used that in conjunction with a runner that we installed in the automation VDC to then start it off with the creation of, for example, the service VDC, where we create all the shared services that will be used for multiple other virtual data center. Virtual data center is the termination of IONOS for some sort of, I would say, in Azure, it's a resource group, and IVS is a resource account. And on IONOS, you have those virtual data centers to structure the resources that you have. So here's a little bit of an architectural overview, what we designed. So on the left side, we have the shared service data center, where, for example, runs Ranger, where a central GitLab instance is a central key cloak who manages all the authentication. There's also Argo CD, which manages all the clusters. And there's, for example, SUSE Vector with the federation who manages all the policies for the other clusters. And on the other hand, we have multiple workload clusters, each connected via OpenSense and a WireGuard connection, so that we can securely communicate with those clusters. Let me try if I can. Yeah. And in those clusters, we are deploying the RKE clusters with SUSE Ranger. And we have the cluster baseline, which automatically gets deployed from Argo CD for each new cluster. So when a cluster gets created, they automatically get a tool set of, for example, Longhorn, Vector, Cert Manager, Prometheus, logging agent, and all that stuff that a cluster needs to be functioning for the customers. And then the customer can also, with the same Argo CD instance, deploy, for example, multiple Nextcloud instances or other services that they want to provide on IONOS. So here we come to the first challenge. You already saw that we have multiple so-called virtual data center. And the problem was those virtual data centers are in different contract for the customers, because that made it easier for the customer to have cost control about those services for the billing of the services to customer or to internal divisions. But the problem was IONOS didn't have any built-in network connections between those data centers. That's why we choose the WireGuard connection. But on the other hand, we had to build an automation to get all the data and all the WireGuard instances seamlessly connected without building each connection by yourself. And when a new OpenSense gets connected, all the other OpenSense should automatically get a connect to those virtual data center. So our solution was to use Ansible to generate the WireGuard connection, store them in HashiCorp Vault, and then used Ansible again to configure on the fly when a new data center gets created. A webhook is triggered and will then trigger all reconfiguration of the existing OpenSense so that the new uplink for the WireGuard connection is added to the existing instances. Yeah, now it comes to cloud automation. For the automation, we choose, as already told, a stack from TerraGrunt, Terraform, and Ansible. We choose Terraform because it's well known for us, it's good documented. A lot of providers are existing, especially for Ranger and for IONOS. They had a really good provider to manage all the services and all the resources that we needed. So since we already know we had multiple data centers that are already nearly identical because they all need an OpenSense firewall, they all should get one or multiple Kubernetes clusters, and they should get the baseline, they should get the same configuration sort of, especially for maybe IP range and some other things. But most or less, they are identical, and that's why we would not just use a Terraform module, because on the other hand, the environment variables are also more or less identical. That's why we added TerraGrunt to the mix, because this allowed us to use the same modules with just some different variable files, and we could easily integrate it in the GitLab CI/CD pipeline to run it, and got multiple data centers in minutes instead of hours. And then we have Ansible. That's because Terraform is really good when you have to deploy infrastructure or when you have to configure services that are API driven. You can use Terraform also to configure services on virtual machines, but it's really ugly because it's not really easy to implement, and that's why we choose to stay at Ansible. And for the VMs like the OpenSense and some other services that are still running on VMs, we choose Ansible to configure those services because we had already existing modules that we could reuse. On the other hand, the community of Ansible is really big, and for, I would say, 90% of the open source software, there are already community-driven projects where we could reuse code, where we could contribute some updates to some existing modules, like the OpenSense module, for example. And that's why we choose those to integrate it in the pipeline. So here's a quick overview how they work together. All starts with the TerraGrunt environment, which is defined in GitLab. Also the Terraform modules, the Ansible collection we use, and the documentation is all stored on GitLab. We have an environment infrastructure repository where the TerraGrunt modules reside. This is the part where the CI/CD is triggered, and TerraGrunt will then run Terraform. Terraform will download the modules, will get its configuration from TerraGrunt, will eventually, when needed, receive or store secrets in Vault, and will then either trigger Ranger to build a Kubernetes cluster or trigger the IONOS API directly to create a VM. And when one of those things are done, then we could execute Ansible and provision the virtual machine if needed.
Question.
Yeah?
Where do you store the Terraform state?
The Terraform state is currently stored encrypted on an object store. And afterwards, we have our running virtual machine provisioned with the services either by Ansible or by the IONOS node driver. And now it's your part.
Yeah, as soon as their VDCs are deployed and all that stuff happened with Terraform, and we have to move on with SUSE, Rancher, and all that stuff. So for the automation and documentation, we had a problem that it should be documented, and there's all the all the changes happening fast, and we have to keep track of all the modules and all that stuff. So we needed a solution to document and keep up to date our documentation. The customer needs understanding of what we do in this environment, and that's why we choose semantic releases, for example, to help release versioning and consistent version management to reduce the human error and speed up the whole release process. So as soon as there are new versions, we use semantic releases to version them and make it clear what was done in the version and all that stuff. It helps to maintain a clear and automatically generated record of changes. We use Terraform docs, which automatically generates from the input and variables and the descriptions of the variables to maintain documentation for these semantic release versions. And all this is running in the GitLab CI/CD pipeline fully automatically as soon as there are Git tags and new releases for our modules we use. And we store these modules in our Terraform module registry, which store them centrally and make it accessible for everyone. So our next big topic was the Rancher IONOS node driver. As we started the project, it was just capable of doing RK1 clusters. We wanted to use RK2 clusters because they are more future-proof, I would say. And the node driver at this time also couldn't only use public networks, which was not suitable for us, as we wanted to make a secure connection between the clients and in the cluster. So we had to come up with a solution for that, and fortunately we had great help from SUSE and great help from IONOS to develop a new RK2 IONOS node driver, which is fully integrated in the UI and make use of the new UI extension in Rancher. So we made the driver ready for RK2 and is now capable of deploying in private lands and has the ability to deploy clusters in RK2. And also reuse a customer-provided firewall, which is important in our case because we made a bit of a custom solution for that. So as we can see, we have a fully integrated UI, and it's you can even use it with the API or a CAD. So you have the full stack of opportunities here. Our next big challenge to face was that the IONOS API was not aware of the IP of the node if it was changed, because we used our own DHCP solution in that case. The problem was that the node driver needed the IP of the node to deploy it in Rancher. Because we changed it in the background with our own solution, the IONOS API wasn't aware of that. So we had to come up with an Ansible rulebook that automatically updates the API in IONOS with the correct IP. And that's a bit of a hacky solution, I would say. But it's the only solution we came up with. But as soon as the node driver registered a new IP change and a new IP, it was then start a provisioning process of the VM via SSH, because it's then aware of the new IP we gave it manually. That's a bit of a hacky solution and a drawback maybe, but on the other side we are able to use any other cloud solution or on-premise solution without to be dependent on the underlying API or DHCP stuff. So as you can see, Rancher requests a VM, which is then created, and it triggers the Ansible rulebook listener, which calls the API of IONOS, and Rancher is then able to deploy the RK2 cluster, including the VMs. I'll just quick second for all the pictures. Okay. So already Toby told you that we also focused strongly on making our baseline as automatic as possible. So we wanted to have standard clusters, standard tools, as we already told you, our tool stack. So we already faced the question which tool make a good baseline. We already found that with SUSE and the whole tech stack. So we wanted to have no manual interactions with the UI, and we chose Argo CD and utilized the application sets, which is perfect for multiple clusters which are similar, but just small little customizations, and the application sets are rolled out on each new cluster. It detects them and rolls out, for example, SUSE Vector and Longhorn, which are also perfect for the template-driven configuration because they make perfect use of the Helm chart YAML and the Helm chart values we provide for them. And it works pretty well, I would say. And in terms of security, we wanted to start with an security by design, so we chose this layer concept, and we also because it's compliant with the BSI, with the Grundschutz in German, which is German regulatory compliance guidelines. So we have multiple data centers in terms of for how we want to use them, and it's a strict traffic flow by design. So even we connect over the internet, we are still secure and have multiple firewalls in use, and still use Vector in the clusters. So we are secure doubled. And we use, as I told you, SUSE Vector for the security in the cluster, as we can secure the cluster BSI compliant and have an automated solution where we can give in the policies by CRD, which is pretty important for our GitOps and Argo CD flow. Otherwise, we couldn't use Argo CD for deployment, for example. So it's a unified tool for all clusters. This is also a challenge, as we already discussed. There's, I think, no other solution which makes it that perfect in the whole life cycle, from dev to production, and it's an all-in-one solution, which makes it perfect for that use case. All right, we are now at a point where we have an automated solution from start to end, thanks to open source tools. It's pretty cool to see them in action. We have multiple similar environments, which is perfect for our use case with TerraGrant and Terraform. A perfect fit for Rancher, and as a central deployment management and security platform. We could deploy indefinitely more environments that can be used in production or testing, and we could use any cloud out there. So we are pretty flexible there, and it's just a cool stack. So we are pretty happy with that solution, and I think we have a great customer use case here for all these SUSE tools. Thank you.